Hello, everyone. In this lesson, I'm going to go over some selected questions from this set of exercise. Okay, so let me tell you where I got this set of exercise. This set of exercises that all the left-hand side, okay, all these left-hand side, let me show you what are the left-hand side I'm talking about. Right here, okay. The left-hand side meaning this part, okay, the left-hand side of all these identities. All these identities on the left-hand side, they are from calculus text. And the right-hand side, however, I worked them out to suit the needs for calculus course, okay? And of course, for both of you at this moment, you may wonder why we want to set it up that way, but very soon, as soon as you get in Calculus 2, you will understand why. In fact, at the end of Calculus 1, you will start to understand why. So with that said, okay, so I selected a dozen questions to show you how they're being proved. Okay, they can be proved. And I wish you guys to work with it as an exercise so that it will not be so difficult when you are in those calculus classes. Okay, so that was the intention. In terms of identity proof, you can find as many as you wish, okay, from any trigonometry textbook. But this set of exercise is specifically preparing you for the calculus course. Okay, so without further ado, let's work on these questions. Okay, we only have a dozen. Okay, so I suggest we all do it from left-hand side to the right-hand side. So starting from the first one, okay, and we want to prove to the right. Okay, so we're going to start from the left. We're going to start from the left. Okay, so let me make the font a bit larger. And so the left-hand side is tangent to the power of 6 multiply secant to the power of 4. And the second question, okay, so let me just put these questions in their order so we don't have to come back and forth. So the second question, well, let's go back to the 200%. So second question. Third question. Fourth. $27, 28, 29, 28, 28, 29, 32, 35, 36, 55, and last but not least, 56. Okay. Okay, so let's start from the first one. Okay, we do from left to right. Okay, because that's how you're gonna see it in calculus text. All right, so I'm gonna make the fonts larger. So let's get started. Okay. This question, knowing where we're going, okay, knowing where we're going. And we know that we're going to have the secant to the power 2 on the end. Tangent to the power 6 unchanged, right? And so we're going to separate secant to the power 4 into secant squared and multiply another secant squared, okay? And the next step, we're going to only keep one secant squared and then convert to secant squared. We're going to use the identity, and this is the identity, which is equals to 1 plus tangent squared. And we're almost there, okay? On this step, secant squared will be replaced by its equal, which is 1 plus tangent squared. And you're done. You're done. So that's how you do it, okay? Number 2, okay? Number 2 is that we also start from the left. The left-hand side is tangent to the power 5, secant to the power 5. So we got secant x tangent x to the end. So we need to have that. So we're gonna split tangent to the power 5 to tangent to the power of 4 of x and tangent x. Okay, so that's still tangent to the power 5. But secant to the power 7, I'm going to write it as secant to the power 6 of x and multiply secant of x. So this is still secant to the power 7, tangent to the power 5, right? And then I'm going to bring tangent to the end. Now I got secant tangent right there, okay? And for the rest, I'm going to convert everything to secant. See, everything in secant. So I got a secant to the power 6. I just have to convert to tangent, right? Tangent to the power 4 will be replaced. But tangent to the power 4, how do we replace it? We're going to rewrite it as tangent squared to the power 2. Can we replace tangent squared? Yes. From here, from this relationship, we can express tangent squared as secant squared minus 1. We just have to subtract 1 on both sides. So tangent squared will be replaced by secant squared minus 1, and that whole piece will replace tangent squared. Okay? And we got to the right-hand side. That's it. You're done. Number 3. Okay. Number 3, we still have left-hand side equals to sine to the power 3 cosine squared. If you look at the right-hand side, the last one is sine x. Everything else is in terms of cosine. So I'm going to split, okay, sine to the power 3 into sine squared of x and the sine x, and cosine squared is going to be copied down, but it's squeezed in between. So sine x will be the last. And everything else turn into, in terms of cosine. So we just have to represent sine squared, right? This piece will be substituted by 1 minus cosine square x. So I hope that's pretty easy, clear for you. And we're done. Number 4, okay, we have the left-hand side Okay, left-hand side is such, right? The last piece is sine x, so I'm going to do the same trick for sine to the power of 3. So I'm going to get sine to the power of 3 to sine squared to sine x. And the rest of the piece will be represented in cosine. Okay, all we have to do is just to replace the sine squared by 1 minus cosine squared. Finished. Okay, you can see it's not that hard. They look intimidating. Okay, but these are the things you're going to need to do when you get into calculus 2. All right. On this one, left-hand side, okay, left-hand side, we have a tangent to the power of 4. Okay, what we wanted to do is that we want to introduce some secant squared. Okay, want to introduce some secant squared. If you look at to the right hand side, we do have secant squared, right? So we're gonna use that, right? We know tangent squared. We have tangent squared here, right? So we're gonna use that. So right here, right? So tangent squared, so tangent to the power of 4 will turn into tangent squared and then squared. Okay? And then tangent squared will be substituted by secant squared minus 1. And then we're going to square these. So we're going to get secant squared. Okay, so we're going to get secant squared and squared again. And squared minus 2ab, 2 times secant squared, plus 1. Okay? But what are we going to do with this piece? On this piece, okay, we will keep 1 secant squared, and we're going to write it as secant squared times secant squared. Okay, and we're going to keep 1 of the secant squared, and this secant squared will be turned into secant squared will turn into 1 plus tangent squared. Okay, so now we're going to multiply 1 plus tangent squared times secant. So we're going to distribute. So tangent squared times secant squared, right? And 1 times secant squared, we're going to get a 1. We've got a 1 times secant squared. So that's how we ended up with the right-hand side. Okay. So this is just be like that. Okay. I know it looks a bit interesting and different, right? But once you get in calculus 2, you will say, aha. Okay? So just wait for that moment to happen. This one, you can see the right-hand side is much more complex. The reason is that we have to do something in order to carry out the calculus task. So starting from the left-hand side, okay, and we're going to write it as 10 and multiply tangent to the power of 4. With tangent to the power of 4, we just did it, right? We just did it. So with that part, we can copy this whole piece. Okay? We can copy that piece. And with tangent x, and over here, we're going to paste it here. Okay? And then, almost there, distribute the tangent x to each piece inside. Distribute it to here, so that's going to be power 3. Let's see. What am I doing? There we go. Tangent. Okay, but anyway, so this is going to be tangent to the power 3. Okay, then this tangent distributed here, and this tangent is distributed here. Okay. It looks slightly, I think at the time I derived this, I have a different idea, but this also works. This actually also works. Okay, so this is another form of it. I'm not going to redo this lesson, but I think this will still work. So basically tangent x times that whole piece, and tangent x times the second piece, and tangent x times the third piece. So we got it right. Okay, this could still work. And tangent x will turn into sine x over cosine x, right? So I'm going to keep this piece. I'm going to keep that piece. All right. So let's move forward. Let's move forward on this piece. I think I must have done it very differently. So this is one way that could also work, actually, for the purpose of calculus. Had I copied the tangent to the power 4. But what if I don't copy it to the tangent to the power 4, okay? I'm still doing the left. Okay, so for a moment, I kind of forgot what I did there. Anyway, but this is going to work. Okay, so this is going to work. Let's see how we're going to make it work. Okay, so we're going to have tangent x and times tangent to the power 4x. Okay, and for tangent to the power 4, we're going to write it as tangent squared times tangent squared times tangent squared. Okay, and with this one, we can we're going to distribute. We're going to make some changes. Okay, so these changes, we're going to do the tangent squared will turn into 1 secant squared minus 1. Okay, secant squared minus 1. Applying this relationship. And after that, we will take this piece, distribute to secant squared. You know what? I'm going to have to double check this part. Okay, so let's just finish this one to see what I got. but it works. It works. Okay. The worst case scenario, I would just have to make some changes. But anyway, like this piece, I may just as well to write tangent to the power 3. Okay. Multiply secant squared. So tangent to the power 3. Multiply secant squared. And then minus tangent x to the power 3. Okay. So this part is ready. This part is actually done. And the next piece, I'm going to keep this part. And working on this tangent to the power 3 part, I'm going to write tangent x times tangent x squared. Oops. Tangent x squared. Okay. And keep everything, but replacing tangent squared, this lever tangent squared, by 1 minus, secant squared minus 1. Okay. So with that said and done, I'm going to take tangent times secant squared. So tangent x times secant squared plus tangent x. And this tangent x will turn into sine x over cosine x. Okay. Oh, well, for some reason we couldn't get over there, but I can be certain these two are both correct. So this might be wrong one. So let's change this question to this piece. I apologize for that, but we got it to work. But this will work in calculus. Okay, this will work in calculus. I will double check that. So number 29. Number 29 on the left-hand side equals to that. Okay. So what we're going to do is that it seemed to have some association with cosine 2x, right? So we're going to work towards that direction. We're going to work towards that direction. So we're going to do, in this piece, we're going to write 1 minus sine, the tangent squared is sine squared over cosine squared. And secant squared is 1 over cosine squared. If we multiply the top, right, by cosine squared, this is a common denominator. So we multiply cosine squared on the top, and we multiply cosine squared in the bottom, we multiply by 1. So the top will multiply 1, the top will multiply this piece, and this cosine squared will multiply 1 over cosine squared. Let's see what we get. Okay. We are getting cosine squared of x minus sine squared of x. The denominator is just 1. Cosine squared minus sine squared, that's just cosine 2x. Finish. Okay. Number 32. Number 32. Number 32, what do we have on the left-hand side? Is cosine multiply tangent, and we want to bring the sine outside. Let's see how we do that. Okay, so this is what we're going to do. We're going to write tangent as sine over cosine. Okay, and then we're going to multiply sine on the bottom. We're going to multiply cosine on the top and cosine in the bottom. Okay, and as a result, cosine times sine, right? So this time we're going to get sine times cosine. And this piece, we just have sine left. Denominator is just another cosine. Okay? And now we're going to factor out the sine on the top. Okay, so bring the sine outside and put it on the sine x. We got the sine x outside. Okay? And the denominator, of course, is the cosine to the power of 4. Okay? And now we're getting closer. We take a cosine to the power of 4, divide into cosine x, plus, and 1 over cosine to the power of 4, all of these in the parentheses. So towards the end, we just simplify. So this piece will have 1 over cosine to the power of 3, and that's it. We got to the right-hand side. Okay, so that will be calculus ready. Calculus ready. Number 35. Number 35. Okay. Number 35, we will primarily using this identity. Okay, this identity is cosecant squared. Okay, cosecant squared equals to 1 plus cotangent squared. Okay, so that identity we're going to use. We got a cosine, a cotangent times cosecant. The end, we have cotangent and cosecant, right? So we're first going to get that. So we're going to split. Okay, so that's the common trick. To the power of 5, going to reduce it to the power of 4. And so we have a cotangent outside. And cosecant reduced to 2, so we get a cosecant x. So that piece is accomplished. And the rest is just everything converted to cosecant. Okay, so we keep this cosecant, we just change this, right? And cotangent to the power of 4, we're going to make it squared and then squared. And that piece inside the parentheses will be replaced by cosecant squared minus 1. Done. We got to the right-hand side. 36. 36. 36, we got left. Okay, cosecant square, cosecant to the power of 4. We wanted to have cosecant squared near the end, so we're going to split, right? We're going to split cosecant to the power of 4 to cosecant squared, and another cosecant squared we're going to put to the right, to the end. So there's a match here. And then we just have to convert everything besides cosecant squared to cotangent. So this piece will be replaced, okay, by 1 plus cotangent squared. Boom, done. Okay, you can see these are calculus ready questions. This process is to get calculus ready. All right, number 55, last two. Left-hand side, we got root of that. Cosine 2x, right? So we have double angle formula here. Cosine 2x, cosine 2x is equal to 2 times cosine square x minus 1. Okay, so we're going to substitute cosine square. We're going to substitute cosine 2x by its equal. So this will be substituted by its equal. So 1 minus 1 will be making 0. So we only have just 2 times cosine square left. So we can bring out the square root of 2. Okay, so here we will have a root 2. And then we have this root of cosine squared. Root of cosine squared is absolute value of cosine. And that's finished. Okay. Be aware that root of x, well, let's use bologna, right? Bologna squared is equals to absolute value of, right? Absolute value of bologna. Okay, so this relationship, okay? Last, for double angle, right? Cosine double angle formula. So this time the left-hand side equals to this piece, 1 minus cosine 4x. The formula we will be using, because the right-hand side involves sine, right? So we're going to use it accordingly. So that's cosine 2a equals to 1 minus 2 times sine squared of a. Okay, we got cosine 4x, right? 4x, we can see this as 4 times 2x, right? So 4 times 2x. 4 to 4x is 2 times 2x. So 2a. So this will be 2x, will be going here. Okay. And now we're going to bring this in. So that piece is copied. Cosine 4x. I'm going to put in a bracket. In that bracket, we're going to substitute it by that equal. Okay. And opened up the bracket. Right, 1 minus 1. And this will turn into positive. And we can drop this plus sign. And next, we got root 2, right, times root of that. And that's going to give us the absolute value of it. All right, so this piece will turn into absolute value of sine 2x. Finished, done. So that's all for this lesson. We covered 12 questions, and there possibly be something I need to correct. There might be a problem there, but you'll see the homework will be reflecting that. But at least the one we derive in the lesson is correct. Okay? Thank you for watching. Have a very nice